When talking about 802.1x, many people will think of the Wi-Fi WPA enterprise authentication, where you need to configure radius. But in fact, 802.1x is not only for wireless, but also for wired networking. IEEE 802.1x is for port-based network access control. It defines EAP, Extensible Authentication Protocol, over wired and wireless networks. In one of my old videos about UniFi AP authentication, I had this diagram. In fact, if you replace the AP with a UniFi switch, pfSense with a UniFi gateway, the exact same diagram also applies to the topic for this video, which is wired.1x authentication. The whole process works in the same way. The client gets authenticated through the authenticator switch or AP, and the authenticator will communicate with the radius servers. Under the hood, EAP is used. And in both of the videos, I use PIP as the EAP type. In this video, I will first use a Mac Mini and a Linux machine as examples to show you how to enable the 802.1x authentication, then how to configure the radius server in UDM Pro, and how to set up your switch accordingly. During the process, I will use Wireshark to show you the network packets in two different places, between your client and the switch, between your switch and your gateway, so that we can understand from end-to-end complete process. In the second part of the video, we will go through all the 5 different options for 802.1x control for a given UniFi switch part to understand what they are, in what situations you want to choose which one. Okay, let's get started. This is my lab environment. I use a UDM Pro as the gateway. I will use this USW Pro 24 switch and 3 different types of clients to show you different types of 802.1x control. A Mac Mini, a physical Linux PC, and a Proxmox with 2 Linux virtual machines. They share the same physical part. First, briefly talk about how a 802.1x authentication works. So you need 3 different parties. Supplicant, which is the client, authenticator, which is the switch for our wired scenario, and then authentication server, which is the radius server running inside the UDM Pro. Before we can do any real testing, we need to configure the radius server. So let me quickly do that. By the way, this video is not about radius. I will quickly show you what I do and then move on. I go to settings, profiles, and the radius. You can see there's a default radius server here already. You cannot delete it. It comes with the UniFi gateway, but you can change it. And if you want, you can create new if you want to point it to external third-party radius servers. But for this video, I'm going to use the default profile. So if I click on it, here I need to configure a shared secret. This shared secret is not used by supplicant or your real client. No, it's used by authenticator. Only the authenticator will directly communicate with radius. So this shared secret is for the switch. Then for the assigned VLAN support, I select wired network for this video. Then I leave these 2 parts to the default value. 1812 is for authentication, 1813 is for accounting. And the default value for this interval is 3600, I believe. It doesn't really matter to this video. Let me reset it to the default value. Then I switch on the tunneled reply so that we can have the reply from radius encrypted. Okay, apply changes. At this moment, if I click on the local credentials, you can see there's nothing configured. Yes, I do have a default radius profile configured, but I don't have any local credentials. At this moment, if I SSH to the UDM Pro, try to see the processes with radius in the name. I don't see any. Why? Because we don't have any credentials configured yet. So let me create one. first username and the super secured password. Then for VLAN ID, this VLAN ID will be assigned to the supplicant or client if the authentication is successful. Here for this particular testing user, let me give it VLAN 88, and then I leave the tunnel type, tunnel medium type to default values, which means tunnel type VLAN, tunnel medium type value 6. There are a lot of possible values. Just to simplify this video, I will use the default ones. So I'm done with the first user. Add it. Now if I go back to SSH, let me run the exact same ps command again. See, this time we have a new process and it confirms UniFi gateway runs free Radius, the very popular Radius server. We are not done with Radius configuration yet. To show you multiple different clients, I need multiple credentials. So let me create another one. Another user, XYZ, super secure password. Then this time for VLAN, let me give it 66, different than previous user. Add it. For now, I added two named users. Later, when we work on the Mac-based authentication, I will show you another type of credentials. We are done with the UDM Pro part, which is to configure the Radius server. Now we need to move on to switch. Now we need to enable the authenticator's role for this switch. There are two different ways to do that. For your global network setting, see the very last one, 802.1x control. If you enable it, you can select a Radius profile. In our case, we only have one, which is default. The effect of this setting is global, which means by default, this setting will be applied to all switches. But in this video, I only want to enable the authenticator's role for this particular switch. So I'm not going to do it this way. Instead, I will go to devices. For this particular switch, I go to settings. Then see here we have a identical 802.1x control configuration, and you have the exact same setting. So I configure it this way. I use the default Radius profile, which we just configured. Apply changes. So now this switch can act as authenticator, but for a switch, it has multiple ports. Each port can be configured in different way when it comes to 802.1x support. That's the so-called 802.1x control. Let me show you. For this switch, if I go to overview, then click on port manager. For this Mac machine, it's connected to port 8. So if I click on port 8, if I switch on menu, you can see by default 802.1x control is false authorized. Later, we will explain what this false authorized and the false unauthorized mean. Just to start showing something works in action, let me change it to author. Later, I will explain what author means, but for now, bear with me. We have the author set here. I'm good with this port 8 control setting. Apply changes. So now we are done with the authentication server and authenticator. We need to move on to the supplicant. Believe it or not, this part is the most complicated part. On the screen, I show you two different operating systems. The left side, a Mac OS. If I go to settings network for this Ethernet interface details, you can see I do have a tab called .1x, right? It's promising. However, if you click on it, you can see it doesn't allow you to configure anything. It simply asks you to reach out to your system admin. What your admin can do is to use a kind of tool called MDM, Mobile Device Management, to generate a configuration file so that you can import to your system to connect to the network using .1x. However, I'm just a home user. I don't have any MDM tool. So in this video, I'm going to take the shortcut. I will manually edit a configuration file. It's not difficult at all. So in the right side, it's a Debian 13 Linux. In the settings network for this Ethernet part, if I go to settings, you can see a security tab. And here I can configure .1x security. Perfect. You know what? In old macOS versions, Apple also provided similar UI. In recent OS, for some reason, the feature was removed. Later in the video, I'm also going to use the right side Linux to manually configure it. But let's start with the left side macOS. As I mentioned, I need to manually prepare a configuration file. Let me directly show you the file. This is the mobile config file. It's a pure text file. Most of the field name and values, they are just dummy values. They are not important at all. The only three values that you need to pay attention to are first this one, the payload type. It needs to be this. Basically, you are configuring the EAP-OL. Do you still remember EAP? Is used by 802.1x, stands for Extensible Authentication Protocol, right? EAP-OL means EAP over LAN. So you want to configure the managed EAP over LAN. Then the next field that you need to pay attention to is this one, the interface. So we need to tell the macOS which physical interface I want to use to connect to wired, right? So to find out your Ethernet port's name, in most cases, if you don't use your external one, it should be EN0. But just to be absolutely sure, you can simply do this. Launch a terminal in your macOS. Run this command. Network setup. You want to list all hardware ports. Okay, the name Ethernet and the device internal name is EN0. This is how you find out the value for this interface. Then the third piece of information is this part. EAP client configuration. Accept EAP type. I use 25. 25 is the easiest one I can use in this video. It's PEEP. Stands for Protected Extensible Authentication Protocol. So some other possible values can be, for example, 13 means TLS, 21 means TTLS. If you want to configure non-PEEP value, you may need to add more configurations to this file. For example, if you choose TLS, you may need to add a certificate payload to this file as well. I want to simplify this video. So here in this video, I'm going to use PEEP, which is 25. That's it. Once you have this file ready, let me show you the settings, device management. So by default, your macOS may look like this. There's nothing. There's no profiles installed. So now I right click on this file, open. See, it says profile downloaded. I need to review the profile. So see what's changed in the device management. I see this file here, but the current status is downloaded. So I need to double click it. It's unsigned because this is for my lab environment. So I'm okay with that. It shows exactly the three crucial pieces of information I just talked about: the setting, the key, the Ethernet interface, and the EAP client configuration. Okay, so let's say I'm okay with that. Click on install. Now it's installed. It's under user. My user ID can use it. Now let's see whether it works or not. Go to network for this Ethernet part. Let me make it inactive, then make it active so that I can force a reconnect to the switch. See, it provided me the account name, password. So let me provide the credentials I configured in the radius, the first one, okay, the super secure password. Let me deselect the remember password option so that next time when I repeat the same connection, I still need to input username password, right? Click on OK. See, it shows green. Connected. See what's the IP address? It is in subnet 88. It is in VLAN 88. Why is that? If you remember, for this first user, we configured VLAN ID to 88. That's why after the successful authentication, this computer received the IP address in VLAN 88. So the whole process is a complete success. To really understand how it works internally, let me run two Wiresharks. The left side Wireshark will capture the packet between the supplicant and authenticator, between the Mac Mini and the switch. The right side Wireshark will capture between the switch and the UDM Pro. Let me make the Mac Mini's connection inactive first, then start the capturing. Started the left side one, then start the right side one. Then you can see in the left side Wireshark, I filter the packets to EAP OL. The right side one, I filter it using EAP. Later, I will explain why. Now let me go back to the Mac Mini for this Ethernet part, make it active. Okay, so now I see this prompt, right? See what happened in the two Wireshark? We only have one packet in the left side. It is from the UniFi switch to this destination. I will explain what this MAC address is later when we discuss the multi-host control type. And it simply says request identity. Then the macOS give me this prompt. That's why I see this dialog. Now let me input the same username password, then deselect remember this information, click on OK. Pay attention to the two Wiresharks. OK. Now it's done in the two Wireshark already. It's just Mac Mini needs some time. Okay, now it's green. We are done again. Let me stop capturing. Let's try to understand what happened in the two Wiresharks. Let's start with the left side Wireshark. Remember, this one captures the traffic between the Mac Mini and the switch, right? So the very first packet is from the UniFi switch to this special destination. If you check the details, you can find the MAC address of the destination. It's this particular value. In fact, it's a hard-coded MAC address with special meaning. So I'm showing you the IEEE document regarding the reserved MAC address. So this particular one ending with 03, this is the one used in this video. In fact, it is for the .1x port-based network access control. In our case, the switch sent a packet to this special MAC address. And then because I activated the Ethernet part of the Mac Mini, the Mac Mini responded with this second packet. See, the infer is response. It's about identity. Then the third packet, see, is very interesting conversation. So the switch asked the Mac Mini, okay, are you able to respond to MD5 challenge? MD5 is not very secured, so that's why in the fourth packet, Mac Mini responded, no, it's legacy, it's too old, it's not safe, I do not want to respond in that way. Then see the fifth packet, UniFi switch tried again, ask Mac Mini, okay, what about protected EAP, right? Do you want to try PEEP? And then see this packet, the Mac Mini was happy, responded back, hello, now let's start the PEEP. So then starting from this PEEP conversation started, and some of them, see, the protocol is showing TLS. However, if you check the so-called TLS packet, you may be surprised because there's no IP address. So normally when we say TLS, it's based on TCP IP, right? You must have IP address. But at this moment, the Mac Mini even doesn't have any IP address assigned yet because the authentication is still going on, right? So then why we even have TLS here? In fact, you see TLS here because Wireshark display the packet in TLS. So what this packet is really about is it is a EAP packet transferred using EAP over LAN, and it encapsulates EAP TLS information. Wireshark is smart enough, can interpret the packet so that it displays it as TLS. I hope it's clear. Now it's time to start look at the right side Wireshark. See, it's very simple. There's only one protocol, it's radius. All these packets are between the switch and the free radius running inside UDM Pro. It's simply the access request, access challenge, and access accept packets. So basically the radius server keeps challenging, and the UniFi switch as a authenticator is simply relaying the response from the supplicant, which is the Mac Mini. And you can see the parts, they are 1812. That's exactly the authentication part we configured in the radius server in UDM Pro. Because I used correct username password, the radius server was happy. Then see the very last response from the radius server. It's access accept. If you check the details of the radius protocol, you can see a lot of attribute pairs. I will show you 3 important ones which are related to our setting. See this one, it's about tunnel type. It says VLAN. Why? Because for my particular local credentials, I set the tunnel type to VLAN, right? And then see this one, the username HZ, because I use this one, these credentials in Mac Mini, right? And see this one, the tunnel private group ID, it says 88. What's this 88? This is the VLAN ID we configured in the credentials in radius. That's exactly why in Mac Mini it received the IP address in subnet 88. Because it's in VLAN 88. The very last packet sent from the switch back to the Mac Mini is a EAP message. Keep in mind, after this packet from UniFi switch to Mac Mini, it simply says EAP success, but it doesn't mean the Mac Mini is already connected to the network, because we are talking about .1x authentication. So this packet just finished the authentication process. Starting from this point, the Mac Mini can start the regular network processes. For example, now I'm only showing you the EAP OL, right? So let me expand the filter. Let me show you DHCP as well. After this success packet, what happened? Mac Mini sent out DHCP discover. Then this IP address, UDM Pro, responded with the IP address for this Mac Mini, right? Why this DHCP can be successfully done? Because the switch allows it to do so. Why the switch allows it? Because the switch knows the Mac Mini has been successfully authenticated to the network. You may ask, this DHCP discover is sent from the Mac Mini to this broadcast IP address. Then why the response is from VLAN 88? Because the UniFi switch knows the authentication's response from radius server is VLAN 88. That's why the switch conveyed the DHCP discover to the VLAN 88 UniFi IP address. We are good with the first demo, which is about Mac Mini client. Let me quickly show you another example. This time, let me use a physical Linux computer. By the way, I connect this Linux computer to the exact port as the Mac Mini. Now the port 8 of this switch is connected with the Linux machine instead of Mac. And as you can see in the .1x control, I still keep it as author. No change here. I'm using Debian 13 in the network setting. I can go to security tab. Then I can enable the .1x security, configure the authentication to use PEEP. And I say no CA certificate is required, just to simplify this video. Then for PEEP version, I say automatic. For inner authentication, I say MS-CHAP v2. I have to provide credentials, otherwise it doesn't allow me to save changes. For this Linux, I will use different credentials. Remember, in UDM Pro, I configured 2 users, right? Let me use the second user, XYZ. Let me see whether I can receive the IP address for VLAN 66, which is different than the Mac Mini example. Apply changes. In this way, I don't need to import a manually prepared profile. I can simply make changes in the setting, right? That's convenient. Now let me enable the interface. Okay, you can tell from the icons change Now it's connected. So if I go to the details, see, it got VLAN 66 exactly as we specified for this user XYZ in Radius server. We are done with the two demos regarding two different clients. Now it's time to explore the .1x control for a given UniFi switch part. For both the Mac Mini and the Linux machine, I use the exact same switch part 8 in this USW Pro 24 switch. In the port settings, you can configure a thing called .1x control. There are 5 options. In the remaining part of the video, we will go through them one by one to explain what each one really means and what will happen in the backend if you choose one. Let's start with Author. You already see the Author works in action for the Mac Mini and Linux, right? But there's one more thing I want to show you. So if I go to the switch setting, remember we enabled the 802.1x on the switch level, right? So if I go to the setting, you can see, yes, I choose the radius profile, which is the default, no problem. But there's another setting. We didn't touch it previously. It is called fallback VLAN. By default, it's none. But I do have a chance to change it to my existing VLANs. So let me change it to VLAN guest. Let's try to understand what this fallback VLAN is really about. Apply changes. In the same way, let me start the two Wiresharks. In the Mac Mini, let me make the Ethernet port active. This time, instead of inputting a correct username and password, let me simulate a bad guy. So let me input a username and password. Okay, see, let's observe what happened in the two Wiresharks. So you can see the back and forth in the second Wireshark, which is between the switch and UDM Pro, right? If you see the very last one, access reject. We didn't see this type of message in our previous testings because both of our previous testings, they were successful. But this time I made an error on purpose. The Radius server returned access reject. That makes sense, right? If you check the details, you can see it didn't reply with any VLAN number because the access is rejected. Then if you check the left side Wireshark, what's this very last EAP? It's success. Is it strange? Apparently it's a failure, right? Why this time it's a success? Because we configured this fallback VLAN. I set it to VLAN guest. So that's why even though my initial radius authentication failed, I do have a fallback VLAN. So this success is about the fallback VLAN. Just to make sure that's the case, if you check the Mac Mini, see, it's showing green color, which confirms it was a success, right? But if you see the IP address, it's in 123 subnet, which is exactly my guest VLAN subnet. Yes, the computer successfully received a guest VLAN IP address. It can do whatever it is supposed to do in guest network, which is nothing, right? In my testing, I use a guest network as the fallback VLAN. But in your case, based on your scenarios, you may configure the fallback VLAN to meet your requirement. Okay. Just want to explain what's the fallback VLAN. Now go back to the .1x control. For this part 8, let me talk about what Author really means. Author means the switch will require .1x authentication if the supplicant tries to connect. And if the client authenticates successfully, traffic is allowed. But if the client fails the authentication, if a fallback VLAN is configured, the client is placed there. If no fallback VLAN, the port stays blocked. So let me show you that scenario, which is I don't have a guest VLAN configured. So let me go back to the switch. Let me change the fallback VLAN to none. Apply changes. Then for this Ethernet part, let me make it inactive, then make active again. Let's observe the packets captured in the Wireshark. Again, let me input the wrong one on purpose. Okay, you see the difference, right? The Mac Mini cannot get network access, so it gives itself a self-assigned IP. So basically this Mac machine cannot do anything by using that Ethernet part. If we check the captured packets, in the right side Wireshark, there's no any difference when it comes to radius authentication, because the very last packet, it is still access rejected. But if you check the left one, see, the very last EAP is failure. Because it's failure, the Mac Mini cannot get IP address. It fails the authentication. So this is the result if you set the .1x control to author, and on the switch or global level, you don't have a fallback VLAN specified. This is the effect. Before moving on, let me show you one last thing, the CLI in switch. So let me SSH to the UDM Pro 24. Go to CLI, EN for enable. Then let me run the command show.1x. Let me see what options I have. So I can see the authentication history. Let me try it. Followed by the port number. So in my case, it's port 8. It shows the unauthorized, authorized history, and what's the VLAN ID, and what's the timestamp, and the corresponding MAC address of the client. Then I can also show the current clients. So show.1x clients, port 8. There's no any clients. Why? Because you can see in the Mac Mini, it's not really connected to the network. So that's why there's no client. Then we can see the current detail. A lot of details about the current situation, but because currently the client is not connected, many values are just initial. So this is the backend CLI command you can use to get more details about your switch part when it comes to .1x control. Now let's move on to the second control option, false authorized. The control name false authorized is not really very intuitive. What it really means is the 802.1x is ignored. The port is always open. It's just like you don't have the .1x enabled on the switch or on the global level at all. Just like nothing's happened, your switch port is just a regular switch port. That's what the false authorized really means. So we can see it works in action. Let me change the port 8 to false authorized. Then let me make the Ethernet port active in the Mac Mini. Okay, the effect is a little bit strange. In the right side Wireshark, there's no any radius packets captured between the switch and UDM Pro. But from the switch, you can see there is a EAP packet. It simply says, okay, it's success without any challenge. And then from the client side, I still received the IP address and the Ethernet port is showing green color. What's the subnet? It's .1, which means it's the default VLAN's IP address. Without going through the .1x authentication, the computer successfully connected to the default VLAN. Why default VLAN? If we check the port 8, you can see I set it so. The native VLAN is default, right? So basically the end result is the same, just like a regular switch port. But internally, the switch does do something regarding .1x. It's just every single time, it's simply a success. So you may wonder, what's the point of this setting? This setting is useful for, let's say, printer, IP phone, or any devices that they are not .1x capable. Let's say you have a printer. You have no way to configure .1x, but you want to connect it to a switch which has .1x enabled. How do you make the connection possible? You set the port to false authorized. Okay, it's easy one, even though the naming is very confusing. Let's move on to the next option. Next option, false unauthorized. What this option really means is the port is always blocked, no matter what the client tries. No traffic is allowed. So let me show you what this option really means. Let me change the port 8 to false unauthorized. By the way, the two Wiresharks, they are still doing the capturing. In the Mac Mini, let me make the Ethernet port active. See, there's only one EAP packet captured in the left side Wireshark, and it's very similar to previous case, right? The difference is this EAP packet is always failure. You can see the effect in the Mac Mini because it cannot connect to the network. It simply gets a self-assigned IP. It cannot do anything. This option is good for scenarios where you want to keep a part physically active but logically shut down. For example, for a unused wall jacket, you don't want bad guy to easily plug in a Ethernet cable then get to your network, right? So then you can set that part to false unauthorized. So you may ask, then what's the difference? Why I need to bother about .1x? Why not simply set this switch part to disabled? Yes, you can do that. But the difference between the disabled switch part and a false unauthorized switch part is if you disable it, there won't be link carriage. The link will be done after you connect the Ethernet cable to your device. It's just like nothing's plugged in because there's no link, right? But if you set the part to false unauthorized, there will be link and you will see the LED light flashing on the RJ45 parts of your device, but it's just the device cannot do anything. That's the difference. Okay, this is another easy one. Let's move on. The next one is about Mac-based authentication. Let me change the part 8 to Mac-based. Apply changes. This time, let me use the physical Linux machine for the testing. The reason is for the Mac Mini, I already manually installed the mobile config. I don't want that profile to impact our Mac-based testing result. For Linux, I can start clean. I connect this Linux machine to the same port 8. Currently, it's disabled. If I go to setting, I can get the MAC address here. In the right side, I go to the radius configuration. For local credentials, I need to create a new user. There's very restricted requirement regarding the username and password. So the username has to come from the MAC address without the separators, the colon signs. And if you have letter in the MAC address, they have to be in capital letter. Pay attention to that. Otherwise, the radial server won't think your MAC address match. So in this way, let me put the username. When it comes to password, it has to be exactly the same as the username. So I simply copy the username and paste as password. That's it. For VLAN ID, just for testing purpose, let me say VLAN 88. Okay, I'm okay with these two other fields. Add the user. Okay. It's done from the radius perspective. And another thing I need to make sure is in the setting for security, I have the .1x security disabled. Otherwise, it won't use the MAC address, right? Now let me enable the wired connection. The first Wireshark captured a failure EAP message, and we can confirm the Linux machine hasn't got a IP address. You can see the icon for wired connection, right? It's not connected. And you also see this error message. Why? Because just to make sure our radius credentials work, for the new credentials, I removed the last letter on purpose for username so that we don't have a correct username password. Now let me add it back. Okay. Yeah, do you see what happened? Right after I corrected the username, I didn't reconnect this wired connection. The system automatically tried multiple times. You can see from the captured packets, and then see the very last one, it is a success. And we can confirm from this wired connection icon is connected. Then if we check the IP address, see it's in VLAN 88, exactly like what we specified here. Okay. And in the CLI for the UniFi switch, if I run this command show.1x details for the part 8, you can see the configuration details. For example, the control mode is MAC based, and interestingly, the authentication type is EAP MD5. It's not PIP. And then this is the client's MAC address, which is authenticated by radius and it's in VLAN 88. By the way, I forgot to mention this time setting for Mac-based .1x control. So let me explain it here. Once the device is authenticated using the Mac-based control, the part is enabled for network. After that, if some bad guy switch the device, connect the Ethernet cable to a different computer, the system won't prevent that. That's a risk. To minimize the risk, you may want to specify a very short period here so that once this many seconds expired, the system will ask the device to authenticate again. If you switch to a new device, it will have a different MAC address, so the new authentication will fail. So just want to mention what this time setting is for. We all know MAC address is very easy to fake. It's not safe to use this MAC-based authentication to start with. You need to consider that before you decide to use this authentication. Okay, now let's talk about our very last control, which is multi-host. I can think of a perfect scenario for this use case. Let me connect a part of my Proxmox server to this port 8. I will try to enable two different Linux virtual machines. They will use the exact same physical part and connect to this UniFi switch. Let me see whether I can use different credentials in the two Linux virtual machines so that they will be in different VLANs. First, let me change the port 8.1x control to multi-host. Apply changes. This might not be as easy as you think. In Proxmox, I have these two Linux virtual machines up and running. From their hardware configuration, you can see for the network device, they use the exact same bridge, which is port 1. And if we check the port 1's definition in the Proxmox server under network, you can see it's simply a Linux bridge, which is using a physical part, right? As I mentioned, I already connected this physical part to the port 8 of the UniFi switch. And for the port 8, I already set the .1x control to multi-host. Now you may think, okay, we are ready to test it out using the two Linux virtual machines, right? No, we are not ready yet. The reason is, do you still remember the IEEE document I showed you earlier regarding this MAC address? So in fact, for all the 16 MAC addresses listed here, they are configured in Linux as part of the group forward mask. I noted down in the diagram. This is a 2-byte mask. It has 16 bits. Each bit represents one of the 16 reserved MAC addresses. For our 802.1x packet to pass through the Linux bridge, we need to enable this particular bit, the 03 bit. If this value is 1, that means the whole 2 bytes, the value is 1000 in binary or 8 in decimal. So we need to change the value for this Proxmox server. So let me show you how to change it. For this server, go to shell. Let me first show you what values we have now by default for these 2 bytes. The value is 0. So what we need to do is to echo a value 8 to this mask. Okay, done. We dynamically enabled this 03 bit, which means now the Linux bridge port 1 will forward the .1x related packets. Now we are really ready to test in the two Linux virtual machines. So in the right side for the two Linux virtual machines, let me start with the left side one. Go to the wired network setting. Then for security, I need to enable the .1x security. In a similar way for authentication, let me choose PEEP. Let me select this one, no certificate, just to simplify this video. And for inner authentication, I'm okay with this MS-CHAP v2. For username, let me use the first test credentials, then the super secured password. Apply. Then see, this icon is changed, it's connected. If we check the details, you can see it got VLAN 88 IP address. So it's successful, right? And then go to the second Linux virtual machine, set the wired setting, go to security, enable the .1x security, quickly change the settings. And for username, let me use the second test username, XYZ, and then the super secured password, apply changes. You can see the icon is changed, it's connected. Let's validate the IP address. Yes, it is in VLAN 66, just like what we said for the second user ID, right? So we are successful. Then to double confirm that, let me go to the CLI. Then for this part 8, let me show the current clients. See, it listed 2 clients. So the first one is authenticated using the first user ID. The second one, the XYZ user ID, right? So they are in different VLANs. This is what multi-host means. So we use the single switch part. We serve 2 different hosts. They can have different .1x authentication. They are in different VLANs. Okay, this ends the whole video. Thanks for watching.